So we have two imaginary people playing chess, and Bill and Gene. And Bill has a 40% chance of winning the first game, which means Gene has a 60% chance of winning the first game. But as you maybe noticed when you're playing games, if you win one, you are inspired to win the next one. But if you lose, you're a little deflated. It's harder to win the one after that. So in this particular example, Bill, if he wins a game, his chance of winning the next one increases by 20%. So if it was 40 the first one, it'll be 60 on the next one. But each time he loses, it drops by 10. So we're going to go through this and see the probability of Bill winning the tournament based on this information. So in the first game, it either goes to Bill or it goes to Gene. If Bill wins, Bill might win the next game, or Gene might. If Gene wins, Bill might win, or Gene does, and etc., etc. Bill, Gene, Bill, Gene, Bill, Gene, Bill, Gene. So, from the gate, we said that Bill and Gene are playing a game of chess, and Bill has a 40% chance of winning the first game. So, in that first game, there's a 40% chance, 0.40, of it going that way, which means there's a 0.6% chance of it going that way. If we follow this branch, Bill has won this game, which means his chance of winning the next one increases by 20. In the game before, he had a 40% chance of winning, so now it should be 20 more than that, so it should be 0.6. Now the chance of Gene winning is whatever's left over. So 0.6 needs an extra 0.4 to balance out. Now if Bill wins that game, his chances to win have increased by another 20%. So it would be at 80. And Gene's chance is whatever's left, so 0.2. On this branch, Bill has lost this game. Now if he loses this game, his chance to win the next one should drop by 10. So instead of 60 that he had here, he should only have 50 now. And then Gene's win will be the balance. So I've worked out everything in the tree that starts with Bill winning a game. So I'm going to do the same thing on the Jill side. If Bill has lost a game because Gene has won, his original chance of winning, 40%, must be decreased by 10. So instead of 40, he has only a 30% chance now, which means that Gene has a 70% shot. On this branch, though, Bill did win that game, so he had a 30% chance before, should increase by 20 because he won. 30 and 20 would be a 50% chance, leaving 50% for Gene. And on this branch, poor Bill, he's lost this one, he's lost the second one. So this time, instead of having a 30% chance to win, he only has 20 because he has to drop by 10, leaving Gene an 80% chance to win. So if you were to ask yourself, what is the probability of Bill winning this tournament? Well, Bill wins as soon as he gets 2 games out of 3. So that would be here, as soon as we reach this place. So either of these 2 branches are wins for Bill. A Bill, Gene, Bill win is a victory for Bill. And a Gene, Bill, Bill win is a victory for Bill. In order to get here, so this is going to be our first option. First, second, third, fourth. In order to land on this particular one, that first branch where Bill is victorious, we had to win this game with a 40% chance, and this one with a 60% chance, and this one with an 80% chance. You hear me saying the word and again and again and again. Those things are multiplications. So I have to do this multiplied by this multiplied by that. 40% chance of winning the first one, 60% chance of winning the second one, 80% chance of winning the final for 0.4 times 0.6 times 0.8. It's not that. 0.4 times 0.6 times 0.8 is 0.192. The second place, where Bill wins the tournament, here, Bill had to win and then lose. So he had to have won the first one with a 40% chance, won the second one with a 60% chance, but then lost the final one with a 20% chance. And 0.4 times 0.6 times 0.2 gives us 0.048. Now, if you'd like, because Bill has already won the tournament here, we maybe didn't need to consider these two branches. In order to get here to here, we would have had to win this. 0.4 times 0.6 is 0.24. And if you check these things up here, 0.192 plus 0.048 adds up to 0.24. So you could have saved yourself some time by just terminating at that point. And that's how tournaments work. Once you win 2 in a row, then you stop playing. But if for some reason we were playing these 3 games, that's how they would spread out individually. We need to get our third option here. To end up at this block, he had to win at 40, lose at 40, and then win at 50. So win at 40, lose at 40, and then win at 50. 0.4 times 0.4 times 0.5 is 0.08. And our fourth way down here is if he loses that first game at 60% chance, wins the next game at 30%, and then wins the third game at 0.5. And 0.6 times 0.3 times 0.5 is 0.09. Now, since Bill can win this way, or this way, or this way, or this way, we have to add those 4 probabilities to get the total chance that he's able to win this tournament. So 0.192 plus 0.048 plus 0.08 plus 0.09 gives us 0.41, which is a 41% chance. Now, you notice that this is different from the 40% chance he had of winning the first game. He's actually more favored to win the tournament than he is to win the first game. And if you look at those branches there, even though there's more probability of him winning over here if he does win the first one, the whole thing together is still 41%. So if you were betting on this particular outcome, you would expect that he has a 41% chance of winning this particular tournament.